Hello, and welcome to this presentation, Understanding Occupied Bandwidth. In this short presentation, we'll discuss the basic technical principles of occupied bandwidth, as well as how occupied bandwidth measurements are made. If you're unfamiliar with spectrum analyzers in general, it might be a good idea to watch the presentation, Understanding Basic Spectrum Analyzer Operation, before continuing with this presentation. We'll start with what would seem to be a very simple task, measuring the width of a signal. There are two main reasons why we might need or want to measure the width of a signal. The first of these we'll call good engineering practice. A modulated signal usually has a well-defined shape and well-defined limits, so if the signal width begins to change or to grow, this is often a good indication that something is wrong somewhere along the signal path. For example, a faulty filter or spectral regrowth caused by an overdriven amplifier. Regulatory requirements are another reason why measuring signal bandwidth is important. Many, if not most, radio communication systems assign signals to defined frequency ranges, or channels. Signals whose power extends beyond these limits can cause interference to neighboring signals. But how do we measure a signal's width? How do we choose to start and stop frequencies? Do we measure it using these limits? How about these? Or maybe even these? Fortunately, there's a very common and well-accepted way of quantifying a signal's width, and this method is referred to as occupied bandwidth. We define occupied bandwidth as the frequency span, or bandwidth in units of hertz, that contains a given percentage of the total signal power. This is perhaps best understood graphically. Occupied bandwidth is measured by computing the upper and lower bounds that contain a certain percentage of total power. In this example, 99% of the total power in the span is contained between the two vertical dotted lines, so the frequency range between these lines is the 99% occupied bandwidth. Most standards call for measuring the 99% occupied bandwidth, that is, how wide, in hertz, is the frequency span that contains 99% of the total signal power. It is, however, possible to measure occupied bandwidth using different percentage powers. The occupied bandwidth of a signal is normally less than the nominal channel bandwidth. For example, a nominally 10 MHz wide LTE signal will typically have a 99% occupied bandwidth of about 9 MHz, as shown in green here. The orange trace shows a 10 MHz wide LTE signal with an occupied bandwidth of 10 MHz. This might sound okay, but actually this is neither expected nor normal. And a nominally 10 MHz wide LTE signal that has an occupied bandwidth of 12 MHz, as shown in red, is clearly a problem. Depending on the modulation type and/or the specification used, there is some variation in terms of what a normal occupied bandwidth should be for a given signal. That said, if your occupied bandwidth is the same as or greater than the nominal channel bandwidth, this is definitely something worth investigating. Occupied bandwidth is typically measured with a spectrum analyzer using a specialized occupied bandwidth measurement mode. The parameters needed to configure an occupied bandwidth measurement are the center frequency of the signal we're measuring, the percent power, which in most cases is 99%, and the channel bandwidth. You might be asking yourself, why do we have to enter the channel bandwidth? Why does the analyzer need this to calculate occupied bandwidth? The simple answer is that setting the channel bandwidth helps the analyzer decide on certain measurement parameters, such as span, resolution bandwidth, and video bandwidth. Once these parameters have been configured, the analyzer automatically calculates the occupied bandwidth and displays the result in units of hertz. Let's summarize what we've learned. Occupied bandwidth measurements are a defined, repeatable way to measure the width of a signal. Occupied bandwidth is defined as the frequency span, in hertz, which contains a given percentage of the total signal power, usually 99%. And under most circumstances, occupied bandwidth is less than the nominal channel width. This concludes our short presentation, Understanding Occupied Bandwidth. Thanks for watching.